again, a lot of students are preparing to become math teachers, and you're looking at this thing over here, and you're wondering, how could a student possibly attack this problem? I put down, two different results, and one is it's not a bad way to go about this over here, and you may want to take a look at that. But I gotta be honest with you, I think there's a better way of going about it. But you should be prepared to see different work, by the way, right? And you probably should read through that. Let me just do a quick read through it for you. Let me erase this over here. And, basically what I do, multiply top and bottom, sorry about that, by the square root of x squared minus 1. What do you get? Pretty simple. And then what do? You split into two terms. You may recognize certain things. For example, you may recognize that some of these integrations are easier than others. But the bottom line is a recognition skill at that point, and you will get an answer to it. All right? So I'm going to say this one, I think, might be a better way to approach the problem. Right? It's a little more familiar, right? So, writing this down over here, this is a trig substitution problem, and we'll go through it step by step. And dx would equal root 3 secant theta tangent of theta d theta. And I got to make a substitution, and the substitution is going to go into this thing over here. And let's take a look at that. And I'll put a little star over here. And what's x? It's root 3 secant. Okay? And let's see, that's not so bad. And what's dx? I need more room. I'll erase this over here. So what's x? It's root 3 secant theta. I just did this. I'm going to do this now. And that's going to be the square root. Well, I got to do x squared. And that's going to be 3 secant squared theta minus 3. Now I got to put this dx down. And what's dx going to be? Root 3 secant theta, tangent theta. Oh, it looks much worse. I got to simplify it and kind of looking through it, sort of carefully. Conditionally the secants cancel, root 3 certainly cancels. And then you get, looking at this square root problem over here, I'm going to pull out a root 3 on it. Whoops. And then you're going to get the root of secant squared theta minus 1, which is tangent squared theta. So what do we get? We would get tangent times tangent, which is tangent squared. Again, I had a tangent here. I pulled the root 3 out from the guy over here and left with secant squared minus 1, which is tangent squared. Square root of that is going to be tangent. All right? Then the question becomes is, do you recognize that guy's... and I don't. So I'm going to have to keep rewriting it. So you get root 3. And let me write this down now for you. And tangent, I'm going to write it as secant squared theta minus 1. I recognize that guy's antiderivative. Let's write that down. Root 3 tan theta minus theta plus some constant of integration. And I gotta go back and do certain things now. And you may wonder what that is. I got to get rid of the theta and go back to x's. So what I'm going to say over here is that x over root 3 is the secant of theta. Where's that coming from? Right over here. I'm going to write down the cosine of theta is root 3 over x. Let me do my right triangle. This is theta. This is root 3. This is x. What's this guy over here? The square root of x squared minus 3. Let's go for it. You get root 3. What's the tangent of theta looking at that picture? The square root of x squared minus 3 over root 3. Again, I'm looking at this picture over here. Minus theta. What's theta? Well, I'm going to use arc cosine. I'm going to use this over here. And that's going to be the arc cosine of root 3 over x plus some constant of integration. Let's look at the answer case, see if we got that. Let me simplify first. Sorry about that. So you're going to get the square root of x squared minus 3. I'm distributing minus the root of 3, arc, cosine, root 3 over x plus some constant of integration. All right, let's look at the key, see if we're getting that. I'm seeing that. I'm seeing this, and I'm seeing that. We're good to go to the next question. Thank you.